Cool. Thanks, Brian. Really excited to be up here talking about APP today. So I'm going to start with an analogy to explain what our platform does. Can anybody tell me what this is? It's a car. It's a Tesla. I think this is a laptop with wheels. And where I'm going with this, when Tesla set out to build a car, they started from the principle of building the first truly electric vehicle that was thought of from bottom to top as an electric car. And this enabled them to design and engineer the Tesla in a way that other conventional car companies who were starting from a combustion engine model weren't able to accomplish. Look at these two different drivetrains. So the top one is also a fully electric vehicle produced by Chevy, the Bolt. The bottom one is the Tesla. And you can see the difference, right? Bolt had this conception that the engine goes in front, and you need a lot of stuff to make the engine work. And so they've just got this mess of stuff there. Whereas Tesla, it's almost like a skateboard with a Mac Mini strapped on top of it. I mean, they just completely reinvented this thing, right? And starting from a platform like this enabled Tesla to not only have a really efficient driving machine, but they built all kinds of other components and features on top of it that made the Tesla an incredibly smooth, powerful, fun driving experience. Tesla, I don't know if you guys know this, but when Tesla was evaluated by Consumer Reports, they got 103 on a 100-point scale. Either Consumer Reports is really bad at math, or they broke the rating system. They were so good. Consumer Reports has now changed their rating system because of Tesla. And that's really what we tried to do with the programmable platform. So we started from the drivetrain for the programmable platform. Brian mentioned our AppNexus programmable bidder product. We released that 2 years ago. And that was, it's incredibly powerful. It enables our customers to bring their full intelligence, their full data science to bear, and to design their own algorithms to decide how to bid, right? But that, for us, that's just the drivetrain. That's our drivetrain. And we spent the last 2 years building the car and the driver's seat around that. And so now, to use our product, you don't have to be a data scientist. You don't have to be an engineer. Just like to drive a Tesla, this is not a stock car. You do not have to be a NASCAR driver to get the performance and the fuel economy and everything else that you get with a Tesla. Same way, now you don't have to be a data scientist or an engineer to operate our platform. It just works. So to explain a little bit more about some of the components that we've built on top of our platform that make it so powerful, let me bring out Megan Arend, who's a product manager, and Ron Lissak, our chief architect, to talk a little bit about one of the things that we've done.
Thank you. Everyone. Thanks, Suzanne. Hey, I'm Megan. I am the product manager for optimization, which means that I'm accountable for the algorithms and backend systems that are intended to achieve better advertiser outcomes. Prior to joining AppNexus's product team, though, I was actually on our services team for about 3 years. And on that team, I worked directly with some of our largest agency and advertiser clients, and also managed a team of traders and trading consultants who either ran campaigns on behalf of clients or taught them how to use our technology to achieve the best outcomes. So both on services and within product, I've had the opportunity to get a lot of exposure to the pain points that traders face on a day-to-day basis. And while I was making these observations, I kept noticing the same problem, which is that overall, trading was taking way too much effort. It took traders an enormous amount of time just to manage the most simple tasks, like spreading a budget out over the lifetime of the flight. To give an example, let's say that a trader had $10,000 to spend over a 10-day period. Easy enough. If she wanted to spend that pretty evenly, she would probably go into console and plug in a budget of $1,000 per day. But let's say that trader came in the next morning and she saw that her line item didn't deliver $1,000 the day before. It only delivered $950. In order to distribute the rest of those $50 through the remaining days of the flight, that trader would have to use really complicated Excel tools, sometimes referred to as budget calculators, which I have up on the screen behind me. She'd rely on Excel to do all of this math for her and then bounce between that, a console report, and console itself to plug in the new daily budgets. And she'd do that day over day for every single line item that she managed. So it was really painful. At AppNexus, we said, okay, we can make this a lot simpler and make it better. So we developed a new product called adaptive pacing. And with adaptive pacing, a user just needs to enter 4 pieces of information. One is their lifetime budget. The second is their flight dates. Third, the percentage by which they want to pace ahead. And finally, the geography that they want to serve in. And on the back end, our adaptive pacing engine will take care of all of that messy management that a trader had previously been doing. So I'm going to pass it to Ron, and he's going to share a little bit more detail about how we did that.
Great. Thank you, Megan. So Megan presented us with the fact that we want budgeting to just work. It's sort of like the self-driving car, that Tesla analogy. We want to tell it where to go, and it should just take care of itself. To build a self-driving car, you really have to build a number of different systems. Systems such as navigation, radar, acceleration, steering, etc. Each one of these systems has a specific task, but only in unison together can they actually create that self-driving car experience. As our user, what we really want from our budgeting system is to enter the where we want to spend and how much, and the system should just do that on its own for you. And so I'm going to talk about the adaptive pacing, the piece of our platform that achieves this. This process for me started a number of years ago when I learned about how old console had implemented pacing. When I'd heard this, I realized that this is a description of a classic control system problem. And it's no secret that there are some standard ways to solve these problems. For example, this very simple to understand equation is one of those methods. This is a technique that's used in thousands of applications across hundreds of different industries, and we brought it onto online advertising. So let's get to some data. What are we talking about? Well, here you can see different prices throughout the day across 2 days for a major US publishers. Clearly, prices fluctuate. It's a market. Prices change, ebb and flow with the supply and demand curves. It's with this environment that the adaptive pacing system has to operate. It has to manage your budget such that at each point in time, you're spending the least amount of money or to achieve your delivery constraints. Sorry, I have to use my notes here. The way the system works is it's always in this market. It's bidding all the time. So it's adjusting the price as demand, for example, lessens. It can decrease the price. When there's more competitive pressure, it's able to increase the price. It's always in the market and always instantaneously looking for the lowest possible price to meet your delivery constraints. So how do we do that? Well, as you've heard, we have approximately 10 billion transactions per day on our platform. This, of course, is worldwide. These 10 billion transactions are occurring across hundreds of thousands of different line items. So effectively, we need to take all this data happening all over the world, ship it through some simple math formula, and then ship it all back to the thousands of computers that are acting on your behalf buying. And we do this all within a few seconds. In fact, we update the prices on our platform every 20 seconds, meaning every 20 seconds we instantaneously compute what is the effective bid price for your particular line item, and we update this platform to do that. Sounds pretty easy, right? Mm-hmm. It took many people and quite a long time to get that to work just right. So once we've had the system that could precisely follow a delivery schedule, we're able to build much more intelligence onto it. And one of those intelligent things we built onto it is the concept of geo-pacing, meaning Why, instead of buying the same amount of money, instead of spending the same amount of money every hour, for example, why don't you follow the traffic patterns of the particular market that you're in? For example, here you see the United States and Japan. They're different. The platform should do this automatically for you. As it goes through as you're setting up, if you're buying in Japan or buying in the United States or buying it anywhere, the platform will automatically adjust itself to doing this. So adaptive pacing is precise, it's efficient, and it's the optimal way to manage budgets on the AppNexus programmable platform. And I'm going to hand it back to Megan, who will show you some of the results.
Thank you. So as Ron just explained, we found that it was much more effective to serve impressions when users were actually online, which makes sense. This is a case study from a major e-commerce retailer in the United States who was running a retargeting campaign. So it was particularly important to them that they're hitting users when they're online. This chart here shows the hours between 2 a.m. and 8 a.m., which is typically considered bedtime hours within the United States. And as you can see, during that period, CPMs decreased pretty dramatically after we implemented geography-based pacing, which is pretty exciting. Even better for the advertiser, the thing that they were measuring, CPC, decreased by about 18%. So it had a pretty big impact, not only for this line item, but for this advertiser on the whole, and all other advertisers that are now using this system. This, coupled with the rest of our adaptive pacing engine, we estimate saves about 2 to 3 hours of trader time per day, because they're no longer spending time bouncing back and forth between Excel and a report and console. Line items spend more when it matters most, because we're serving impressions when users are online. And finally, advertiser dollars are stretched farther because we're bidding more efficiently throughout the day. In short, it made trading and budget management a whole lot more efficient.
Great. Thank you.
So I struggled for a while to think of the proper analogy to use in our Tesla example. Is this the cruise control, or is this the traction control? You know, I don't know if any of you ever gone to a car dealership and been like, you know, I really don't want the anti-lock brakes or the traction control. I'm a really good driver, and I don't skid. Great at braking. In a sense, the cool thing about what you've built is that from a user perspective, you're just doing pacing. Like every trader always does pacing. And what you're saying is that behind the scenes, we can use that to drive 36% better outcomes for the user. And I think that's sort of where we've changed the paradigm here. On top of this platform that we've built with the underlying programmability, we can do all of these things that sort of magically make the system get better outcomes than you get elsewhere. I think the hard part from a user perspective, think of your car, is I don't really know if my car's ever turned on traction control. I don't. I mean, maybe it did. I've never crashed, which is good, like knock on wood. We're trying to do things that are behind the scenes that make your outcomes better. But it kind of begs the question, like, are we saying that for all the traders, you know, who spend time doing this, that they're no longer necessary? Are we now saying we as a system can make the human aspect of programmatic go away?
So I don't think so. I think what users are doing today in the current paradigm is they're setting up bids for everything. So they're doing all of this pacing work. What we think of as micro-optimization, they're spending all their time doing that today. We think that the machine or our platform can do that better and more efficiently in most cases. But, oops, too many slides. But what humans are really good at is intuition, and this is something that's really, really hard to program into any system. So while they're setting up these bids, they're making decisions about, you know, where to start and how to, you know, what is this item I'm setting up? What is it like? What is some other, you know, past performance I've seen that I can bring to bear into this situation? And so while we were building, you know, the things that, that Megan and Ron just told you about, we were also thinking a lot about how can we layer on that special sauce that only people can add, that intuition? How do we layer that on and let people really influence the machine? And I think it makes sense probably to bring out Rez, who's our product manager, who led all of these efforts. Rezwan Khan.
Thank you, Suzanne. So as a human being, I completely agree. We need to figure out how to make the man and the machine work together. So when Brian posed this problem to us around 6 months back, we thought to ourselves, all right, what do we actually need to do to make this system work? And there are 3 things in my mind that the system needs to do to be able to bring man and machine together. So number 1, the system should just work, which means if you have a delivery goal, you should be able to put it in the system, and we should be able to hit it. If you have a performance goal, like a CPC goal, you tell the system what the CPC goal, and we should be able to hit it. It should be as simple as that. Number 2 is it should be expressive, which means if you have ideas or tactics or strategies which are nuanced, interesting, fun, and you want to try them out in the system, you should be able to express that in the system. And number 3, it should be accessible. So while using APIs and programming languages such as Bonsai is really cool and really powerful, what people really want at the end of the day is being able to log into a UI and just set things up and let it go and make it work. So how do we solve these 3 problems? How do we make it just work? How do we make it expressive? And how do we make it accessible? So I'm going to touch on these 3 themes over and over again. So let's talk about the just works piece. That's actually pretty simple. Well, not simple. It's actually really hard, but Megan and Ron are really smart, and they solved this problem for us. And what you need to do is you need to set the budget and set the KPI. Pretty simple, put 2 numbers in, tell the system to go. And how do you make it expressive? So I'm going to do a little dance here, not literally, because that would be terrible, and you don't want to see that. I'm going to show you a video demo and do a voiceover and try to keep up with the pace of the video demo. And if I'm off, just bear with me. Cool. So I'm going to show you a demo of the tool we're going to talk about today, programmable splits. So the advertiser has set up $500 and has a $1 CPC goal. But the trader has additional insights. They think that certain domains would perform well. They also think that certain segments would perform well. And the advertiser has told the trader that, hey, my users who love the product are in Abu Dhabi, so spend some money in Abu Dhabi and see whether it works. And they want to do it in a manner that they can tell the system to try these things out. But if it doesn't work, make sure the system doesn't underdeliver. Make sure the system doesn't not hit the CPC goal that you have set up. So how do you do that? So I've set up 3 splits called domains that work, segments that work, city allocation goals. So I'm going to go and show you how to set this up. So I can select domains as a condition for a split. And I can select my domains, CNN.com, MSNBC, and the Wall Street Journal. So whenever impressions fall in these 3 domains, it would be applied to this particular split. And I want to do the same thing for the segments, the segment split. So I'm going to add segment as a feature and add 3 segments, age 18 to 44. So whenever impressions fall under those segments, it would apply to those particular splits. And then I want to add a split for the city because the advertiser wants to spend money on Abu Dhabi. And then I can tell the system, try to spend 20% of the money and 10% of the money of the line item there. And what we'll do in the back end now is we will try to experiment on these conditions. We'll try to see, does it actually hit the delivery goal? Does it actually hit the CPC goal? And if your intuition is right, if your hunch is correct, you'll see much better performance over what the machine can do. And if it's wrong, don't worry, because we'll still hit the delivery goal. We'll still hit the CPC goal. We will make it safe for you to experiment. And that's really what the power of the system does. You can tell it to do interesting things, but you'll still be able to rely on the fact that it will hit the delivery goal and will hit the CPC goal. You can do the same thing for cities. And the features are limited to not just domains. There are 40 different features that you can mix and match in any combination that you want. And all these features are available in Bonsai, and it's available in the UI now for you to create these complex splits and rules for. And as you can see, there are geo-based features, segments, viewability, everything. So let's say you have additional insights that you think that the domain-based split would only work if you layer in browser and also viewability. So now you can go create that rule where you can say, hey, if the, let's go to the browser. There you go. If the browser is Android, and if the viewability rate is over 50%. Oh, that's terrible, 50%. There you go. Now you have a complex rule. And that's it. It's meant to be as simple as that. And once you set it up, you let it go. The system would try to experiment with these strategies, with these tactics, and balance between allocation, performance, and being able to execute on these expressive tactics that you put in. So 3 themes again. How do we make it simple? How do we make it expressive? How do we make it just work? It's very fast and easy to set up. This took me 60 seconds-ish to set it up. In a typical system, it might take you anywhere between 10 and 30 minutes to set up these complex rules. It's literally a program in the back end. So everything that you set up is translated into this program. And everything you saw on the screen before is this code. So imagine just being able to write code with an UI and have our system intelligently execute this code in the back end. And everything else just works, which means we will do supply optimization to find the most cost-effective supply. We can do delivery and pacing optimization to hit the delivery goal and the pacing goal that you have. And we'll do performance optimization to hit the CPC goal that you have as well. So everything just works together. And the real power of the system is we are, like I said, we're trying to make man and machine work together. We think that the machine should not hinder the man should not hinder the machine. And how do you take the best of what a trader can do and apply it to the machine and make it work together intelligently and seamlessly? And by doing so, we feel that we can empower you to delight your customer, and that will just lead to better outcomes, not for your business, but for your customers and for all of us. Thank you, everyone.
So I think that brings us back full circle to our Tesla. So have we demonstrated the connection between the car and the platform?
I think so. I think the key takeaway is, I said this isn't a car, it's a laptop with wheels. It is a car, and that's the important thing. Our platform is going to still feel like a DSP, but everyone will know under the hood we have the most powerful technology and the most powerful programmability that the industry has probably ever seen.
That's right. All right. So going back to my opening kickoff, I'm super excited about APP. I really am excited that the best dressed person on stage just wrote a program in front of you. Get it? And I think that's where we're going, is something that has all of the ease and comfort of other ad tech platforms that you've seen for the past 20+ years, but with an entirely different way of actually executing behind the scenes that drives dramatically better results. Over the course of the day, you're going to hear about transparency, you're going to hear about brand safety and fraud protection, you're going to hear about more machine learning things, but I want you to keep in mind this idea that we can put all of this power in a package that allows anyone in this industry to get the full results and effectiveness of this system we've built. I want to say thank you to all of you, but also I want to say thank you to all the AppNexians watching around the world. There are hundreds of engineers and product managers and data scientists that have really helped build this platform. This is based on a ton of experience from you, all of our customers. We've been listening and watching you work. There's a bunch of services people and account management people. Everyone has worked really, really hard together for 4 years to build this platform. I'd like to say thank you, all of you, and to all the AppNexians for everything that's made this possible. Yep. Thank you very much.